When I go to neuroscience meetings, the huge emphasis is on the central nervous system. There really is limited interest in the peripheral nervous system, although it sometimes surprises CNS neuroscientists to hear that there are more neurons in the gut, in the intrinsic plexuses in the gut, than there are in the spinal cord. I mean, it's a massive nervous system and it shouldn't be neglected. The way co-transmission was proved in the gut and in the periphery was often with very elegant surgical procedures where you isolated particular pathways. This is, of course, much more difficult in the brain. To do the experiments to prove co-transmission wasn't nearly so easy, although, in my opinion, there were clear hints, because if ATP is coming out, let's say, with glutamate in the hippocampus, and it breaks down to adenosine, and it was well known that adenosine was a prejunctional modulator, where did it come from? It could have easily come as a co-transmitter. And I always try to persuade the hippocampal people to do another experiment, because when you get co-transmission, you often get synergism between the two major neurotransmitters, co-transmitters. Well, synergistic means that when two agents are applied, that they don't just add to each other. It's not an equal response which is added when you put the two together. You get an enhanced response. And that means synergism is when one of the agents enhances the response of the other, by a mechanism, again, which is not terribly clear yet, although there are some papers about this. We've certainly shown synergism in the vas deferens between noradrenaline and ATP. A tiny amount of noradrenaline enormously potentiates the response of ATP on the smooth muscle of the vas deferens.